Hey guys, Mrs. Butcher here, and this video is over rational inequalities. This is the extension to the chapter in our book. For doing these, we're going to use three different methods, and we've done inequalities before. We're going to use a table to solve, we're going to use a graph to solve, and then we're also going to do this algebraically. I'm using a number line. And I'm going to show you all three methods, and yes, we do expect you to know all three methods. Alright, so this first one says use a table to solve x squared minus x minus 6 all over x minus 1. And the first thing we want to do in any of these instances is change that so that it's a 0. And in order to make this less than or greater than 0, we're going to have to subtract x from both sides in this case. And then in an algebraic way, you would have to actually simplify all of this. But since we're going to use our calculator in a table, you can enter this in. Just make sure that when you put it into y equals, put parentheses around this, make it a stacked fraction, put parentheses around this, and then have the minus x separately. You have to have those parentheses in order to get this right. So you're going to put that in y1, and then you're going to just look at the table. Hit second table, and you should get something like this. And here's our table. Now we are looking for values in that table that are greater than 0. And greater than 0 means positive. So if we go through here and circle all the positive y values, that would be everything from here on up. And you can scroll through your table and see that it is still positive, going on and on and on. Alright, so that means that the asymptote is right here at x equals 1. So we're going to start at the asymptote, and all the x values from 1 on down, so less than, so x is less than 1, all the x's that are less than 1 give you y values that are greater than 0. So that's the answer to the inequality. For this next example, the instructions say to use a graph to solve. And this one already has a 0 over here, so you don't have to do any subtracting, but you always want to make sure that that's a 0 over there before you start. And then you're going to put it in the graphing calculator and look at it. Things we know about this, we've got a vertical asymptote at x equals 2. We've got a horizontal asymptote at y equals 4. So we're going to look at the graph. It's going to look like this. I've got the asymptotes in here, and I've actually shaded where is the graph less than 0. It's underneath the x-axis. So what we want to do is figure out what part of our graph, ooh, that went around, is in the shaded part. So it's all of this. And we want to know what x's go along with that. So we can find out that that value right there, that's your x-intercept. And remember, to find your x-intercept, you just set the numerator equal to 0, so that would be negative 3/4 is less than x is less than, and then it's not going to go any further right than this asymptote because it's like a force field wall that it can't pass, so that's at 2. So our x's are only between here and here, and that would be from negative 3/4 to 2. So you could write it in set notation as well if you wanted to. Negative 3/4 to 2. Okay, the last method is to solve it algebraically. And when you do that, because you don't always have a graphing calculator to put it in and look at the graph of the table, just make sure that you, same rules, make that a 0 first. So we're going to take x plus 1 over x minus 3. You can't cross multiply when you have an inequality like this. It's not going to help. So we take minus 3 is less than or equal to 0. And then we need to combine this into one fraction. So that means I need to multiply this by x minus 3 over x minus 3 to give it a common denominator. So I've got x plus 1 minus 3 times x minus 3, which is all over my common denominator x minus 3. And we can simplify a little bit. We've got 1x and minus 3x would be negative 2x. And then we have 1, and then minus 3 times minus 3 is plus 9, and 1 plus 9 is 10. So negative 2x plus 10 over x minus 3 is less than or equal to 0. And from here, you can actually factor out negative 2. So let's go ahead and write this as negative 2 times x minus 5 over x minus 3. Because that's completely simplified when you factored it. Now what we're going to do is identify our critical x values. And the critical x values are where your numerator and your denominator are equal to 0. So if we set the numerator equal to 0, we would have x equals 5. And if we set the denominator equal to 0, we would have x equals 3. Those are the critical x values. That's actually going to be your vertical asymptote and your x-intercept. So now what you're going to do is draw a number line. And you're going to put those critical x values on your number line. So here we've got 3 and 5. And we know that x can't actually be 3 because they need to be dividing by 0, so I'm going to put an open circle here. We know that x does equal 5 at the x-intercept. I'm going to put a closed circle here. But those are the critical x values. That means I have an asymptote through the graph here, and the graph is going to cross one way or the other right here. So that means what I want to do is check my intervals. I've got an interval between negative infinity and 3, an interval between 3 and 5, and an interval between 5 and infinity. Sorry about the bell. Once you've divided your number line into these intervals, just pick a value in each interval and check and see if it's positive or negative. So let's pick something less than 3. I like 0 because 0 is an easy number to plug in. And I plug it in to negative 2 times 0 minus 5 over 0 minus 3. And I want to know what does that equal, and that equals 10 over negative 3, so it's negative. Alright, let's plug something in between 3 and 5, like 4. So we'll go negative 2 times 4 minus 5 over 4 minus 3 gives you positive 2 over positive 1, which is positive. And then something greater than 5, so like 6. So we'll plug in negative 2 times 6 minus 5 over 6 minus 3 gives you negative 2 over 3, and negative 2/3 is negative. So I'm running out of room here. But what you're looking for is less than 0, which means negative. You're looking for the regions that were negative, and there were 2 of them. So it was this region here and this region here. So we would say x is less than 3 and greater than or equal to 5. Less than 3 because it can't be 3, there's an asymptote. But greater than or equal to 5 because it can be 5, it can touch 5. And so I'm going to write that down here very small. X is less than 3, x is greater than or equal to 5. That's your final answer. And I know that's kind of confusing, so I'm going to do one more example of these. Okay, so we've got 3 over x plus 2 is greater than 1 over x minus 1. And I know many of you are going to be tempted to cross multiply here, but that'll only give you one value of x. And we're going to have more than one because we're going to have some intervals. So what you're going to do, first thing, is subtract the 1 over x minus 1 so that it says greater than 0. We always want it to have a 0 there. And then to subtract these guys, we need a common denominator. So we're going to go with 3 times x minus 1 minus 1 times x plus 2 all over the common denominator of x plus 2x minus 1 greater than 0. If we distribute our 3 and our negative 1 and combine like terms, we have 3x and we have minus 1x gives us 2x. And we have -3 and -2 is -5. So 2x minus 5 over x plus 2x minus 1. Now that we've simplified our fraction, we need to find our critical x values. Remember, those are going to be the zeros of the numerator and the zeros of the denominator. So if we set the numerator equal to 0, we'd get 5/2. If we set the denominator equal to 0, we would get -2 and +1. So we're going to put those on the number line. The lowest we want is -2, -1, 0, 1, 2, 3, so 5/2 is right there. Alright, so -2 and +1 are the asymptotes. It can't actually equal that, so I'm going to put open circles on those. And then 5/2 is the x-intercept, so it can be that. I'm going to put a closed circle on that. So we actually have 4 regions now. We have this one. We have -2 to 1, 1 to 5/2, and 5/2 to infinity. That means we have to test one value in each region. So if we pick something that's less than -2, we plug in a -3. Then we've got 2, so I'm plugging it in right here to this one to see if it's positive or negative, to see if it's greater than 0 or not greater than 0. So I've got 2 times -3 minus 5 divided by -3 plus 2, -3 minus 1. That gives you -11 on the top, +4 on the bottom. That means it's negative in that interval. So let's use some color here, and we'll put a big O minus sign right here, because it's negative in that interval. Alright, let's plug in something between -2 and 1, and 0 is the easiest thing to plug in. So 2 times 0 minus 5 over 0 plus 2 times 0 minus 1. 2 times 0 is 0 minus 5 is -5. 0 plus 2 times 0 minus 1 is -2, and -5 over -2 is +5/2, so that's positive. I'm going to put a big O plus on this interval. Alright, something between 0 and 1, between 1 and 5/2, the easiest thing to plug in would be 2. So 2 times 2 minus 5 over 2 plus 2 times 2 minus 1 is going to be -1 on top and 2 on bottom. That's negative. So I know that wherever the graph is in here, it's below the x-axis. And then something greater than 5/2, so like 3. 2 times 3 minus 5 is 1 over 3 plus 2 is 5 times 3 minus 1 is 2. That's 3 minus 1. 3 minus 1 is 2 times 5 is 10. But it doesn't really matter what it is. We know it's positive. And so that interval is positive. So we don't actually have to know what the graph looks like. We can just test different parts of it. And now, since we were finding greater than 0, we want the positive regions. So our final answer is going to be that x is between -2 and 1 and greater than 5/2. So I don't know where to write that. I'll put it on the next page. X is between -2 and 1, and it is greater than 5/2. Or we could do an interval notation, 5/2 to infinity. Either one of those would be fine. And that's the algebraic way to do it. Alright, so that's the end of this video. Let me see if I can find you a funny joke. Yes, saved this one the other day because I thought you guys would find this funny. All right, have a good night.